Hi everyone. Yesterday I gave an introduction to digital to analog conversion. What is meant by digital to analog conversion? Based on the information of digital data, we are going to change any one of the attribute of analog signal. What are the attribute? Amplitude, frequency and phase. By changing any one of this attribute, we are going to get different version wave. Okay, we will get the different version of wave. It is called as digital to analog conversion. I told her there will be four types of digital to analog conversion. First one is ASK, second one is FSK, third one is PSK, fourth one is QAM. Today I am going to explain only ASK and FSK. ASK means amplitude shift key. Shift key is nothing but changing or modulation. Okay. Frequency shift key. I am going to explain only these two, ASK and FSK. Before going to explanation of ASK and FSK, what is meant by carrier signal or carrier frequency? Nothing but sender produces high frequency signal. This is called as carrier signal or carrier frequency. What is meant by carrier signal? Sender produces a high frequency signal. This is called as carrier signal or carrier frequency. Now I will explain ASK, amplitude shift key. What is meant by amplitude shift key? Here both frequency and phase remain constant for all signal elements. Signal element is nothing but zeros and ones, means signal data. Okay, signal element is nothing but signal element will be represented by sequence of zeros and ones. Okay, here both frequency and phases remain constant, means we are not going to change the frequency and phase for all the signal element. Only amplitude of the carrier signal will be changed. Only we are going to change the amplitude of the carrier signal, so we call it as amplitude shift key. Why we are going to change the amplitude of the carrier signal? To represent the different signal element. To change the signal element, nothing but to change the sequence of zeros and ones. So we are going to change the only amplitude in the amplitude shift key. I told that what is meant by carrier signal. Carrier signal is nothing but sender produce the high frequency signal. Okay, how this will be implemented? It is implemented by two levels. It is also called as OOK, means on off key. Okay, after applying this change to amplitude, we are going to get this type of wave. Okay, this type of signals or waves are going to send. You can observe this here. We are going to get for 1 bit this type of wave will get. For 0 there is no wave, means the wave will be off here. Okay, for 1 wave is on, for 1 is wave is on, for 0 there is no wave. After applying changes to amplitude of the carrier signal, we are going to get this type of wave. Okay, and here the R value will be 1. S means What is mean by S? S is nothing but number of data element per second. What is N? N is nothing but bit rate. Okay, bit rate is nothing but bit per second. Okay, this is the formula to calculate the bandwidth of ASK. Okay, B is equal to 1 plus D into S. Okay, here FC means carrier frequency, means it is the between the value of starting and ending frequency. The how we are going to calculate the FC means in between starting frequency and ending frequency we are going to get the carrier frequency. Okay, I explained ASK. How we are going to implement the ASK by using binary ASK. Here implementation of binary ASK means binary amplitude shift key. Here we are going to use unipolar RNZ. RNZ is nothing but non-return to zero line coding scheme. Okay, we explained already unipolar as RNZ. How we are going to represent? The one will be positive signal, 0 will be 0 voltage only. For one positive, here also one is there, so I will continue this one positive voltage, and for 0 I will represent 0 voltage like this. This is unipolar. The bit 1 represents the positive voltage, the bit 0 will represent the 0 voltage. Here 1 0 1 0 1 0 double 1 0 is called as bit or signal element. We are going to call it as signal element. Okay, I told that implementation of BASK nothing but binary amplitude shift key. Here we are going to use line coding as unipolar NRZ. Okay, this is representing unipolar RNZ. Okay, this one up to here it will represent unipolar NRZ. How we are going to implement this binary ASK? This is the diagram. Here we are going to use input unipolar NRZ for the multiplier with input from the oscillator carrier frequency. What is the oscillator here? Oscillator is generate specific frequency of a signal. So it will going to generate here carrier frequency. After combining this input and frequency from this oscillator, combining these two will get the ASK waves. This is the output of these two signals. Okay, you can see that this is unipolar NRZ wave, this is carrier frequency wave. Combining these two we are going to get the amplitude shift key wave, means For 1, the wave is on. For 0, the wave is off. For 1, wave is on. For 1, wave is on. For 0, wave is off. This is the amplitude shift key signals. You are going to get this type of ASK waves. Okay. Next one is bandwidth of ASK. Bandwidth of the ASK is given by the formula B is equal to 1 plus D into S. Here B represent the bandwidth, D represent one of the factor depend upon modulation and filter process, and S represent the signal rate. Here B is depend upon S, or B is directly proportional to S, means B value, S value will be same. Okay. Based on this formula, we are going to see one of the example problem. Okay. See here, this is the one example program. Here we have an available bandwidth of 100 kHz, which snaps from 200 to 300 kilohertz. What are the carrier frequency and bit rate if we modulate our data by using ASK, means amplitude shift key, with D is equal to 1. Okay, this is the problem statement. Here they are going to ask to find the carrier frequency, nothing but FC, and bit rate. What bit rate is nothing but we have to find the N. We have to find here FC and N. N is nothing but bit rate. Here they are given the data bandwidth is 100 kilohertz. Okay, and they give the snap between 200 Hz and 300 kilohertz. Okay, why they are giving this two frequency, means to find the carrier frequency. Carrier frequency is nothing but middle between the F1 and F2. We will get 250. 250 is the answer for carrier frequency. Okay. Now I have to find the value of, I have found FC. Now I have to find the bit rate. Okay, bit rate is nothing but N. I have to find. Now I am having the value for B, means bandwidth value is present. I will write the formula of bandwidth of ASK. Here B is equal to 1 plus D into S. Okay. Here I have the value for B, that is 100 kilohertz I applied, and have value for D. D value is 1 into S. Okay, I applied all the values, and here 1 plus 1 2 I written here, and S I written here. What is S here. S is nothing but signal rate. This represent signal rate. What is the signal rate formula? Signal rate is equal to bit rate into 1 by R. Okay, I will substitute S formula here. S is replaced by N into 1 by R. So here 2 into N into 1 by R. R value, I told that always R will be 1 here. Okay, so I will take the R value is 1. Okay, so I will substitute 1. I will get 1 divided by 1, 1 only. So I am going to get 100 is equal to 2 into N. Now I will calculate the N value. N I will keep as it is, and 2 I will take this side, means I will get N is equal to 100 by 2, means 50 kHz I am going to get. So I calculate I'll find the answer for N. N is nothing but bit rate. I calculated FC and N. Okay, this is the end of the problem on bandwidth of ASK. Next type of digital to analog conversion is FSK, frequency shift key. Here both amplitude and phase remain constant for all signal element, means we are not going to change here amplitude and phase. Here we are going to change frequency of the carrier signal to represent different signal element. How we are going to get this frequency shift key signal? By implementing binary frequency shift key. Here two carrier frequency are used, F1 and F2. In ASK we are only using one frequency, carrier frequency, that is FC. Here we are going to use two carrier frequency, F1 and F2. When data element is 1, first carrier signal F1 is used. When data element is 0, second carrier frequency is used. So here we are using two frequencies. In ASK we are only using one carrier frequency, that is nothing but FC. Okay, here you can observe binary frequency shift key. After applying this, we are going to get this type of signal. Okay, for one there is variation in the signal, means we are going to speed up the frequency for 1. For 0 remain constant, means constant signals will be there. For 1 speed of the frequency, for 1 here also we are going to speed of the frequency. For 0 the frequency will be constant, means the 0 waves are constant. For 1 the frequency will be speed up and some random signals will be gained like this. Okay, and here R value is equal to 1, S is equal to N. S means signal rate, n means data rate or bit rate, b is equal to means bandwidth of FSK is 1 plus d into s plus 2 delta f. This is the formula to calculate the bandwidth of FSK. Okay, this is the bandwidth of FSK. Next, how to implement binary frequency shift key. Next one is how to implement BFSK, binary frequency shift key. Here also we are going to use line coding technique is unipolar N or Z. Here we use two types of binary frequency shift key, coherent and non-coherent. Here we are going to use coherent BFSK, not going to use non-coherent BFSK. Why? We are going to differentiate to understand the reason. Okay, here for coherent, the phase continues through the boundary of two signal element. Means you see here in this diagram, one is one signal element, 0 is another signal element. According to this, the phase continues through the boundary of the two signal element. You can see that this one is boundary between 1 and 0. The phase is continuous. There is no break in between 1 and 0. But in non-coherent, here phase may be discontinuity between the one signal element and the next beginning. Means there may be a discontinuity between 1 and 0. Next difference between coherent and non-coherent, this is implemented by using one voltage control oscillator. What is meant by voltage control oscillator? Nothing but change frequency according to input voltage. What is meant by voltage control oscillator? Changing frequency according to input voltage. For example, if input voltage is positive, nothing but 1, the frequency will be high. Okay, if the input voltage is 0, the input voltage is 0, then frequency of the signal will be constant. Okay, the frequency of the signal will be constant. Okay, here this is implemented by treating BFSK as 2 ASK modulation. Means we have to divide the BFSK as 2 ASK modulation. Means we have to use 2 amplitude shift keys. Okay, and we should use 2 carrier frequency. So we are not going to use coherent BFSK. We are going to use only coherent BFSK. Okay. when the amplitude of a N or Z signal is 0, means when the voltage is 0, the the voltage control oscillator keep its regular frequency, means whatever the frequency is there, it's not going to change here when the NRZ signal is equal to 0. But when NRZ signal is equal to 1, the voltage control oscillator increases its frequency, means it's going to increase the frequency. Here it will keep regular frequency, but when signal is 1, it's going to increase the frequency. Okay, in this diagram you can see that we are used voltage control oscillator. This is the input NRZ, unipolar NRZ signal, and we are getting BFSK signal. This is the output of this input unipolar RNZ. You can observe here, this is unipolar, this is unipolar NRZ. Okay, this is carrier frequency, and this is the output of this. Okay, when NRZ is equal to 1, we are going to increase the frequency here, so we get more signals here, signal waves. Okay, here we are going to get constant frequency, means we will maintain same frequency. Here you can see that whatever the wave here, the same way present here, but for one there is change in between here and here, means we have increased frequency here. Here also we increase the frequency because of 1 unipolar NRZ is equal to 1 here. Here unipolar NRZ is 0. We maintain same wave as it is. Here also same, here also same. Okay, bandwidth for the BFSK, binary frequency shift key. Frequency shift key has 2 ASK signal, each with its own carrier frequency F1 and F2. So the formula is bandwidth is equal to 1 plus D into S plus 2dF, where 2 delta F is equal to difference between F1 and F2. Okay, we will discuss one example problem on bandwidth of BFSK. Here you can see the statement. We have available bandwidth of 10 kilohertz, which snap from the 200 to 300 kilohertz. What should be the carrier frequency and bit rate if we modulate our data by using FSK with D is equal to 1? Here they are going to ask to find carrier frequency, nothing but 2 delta F and bit rate N. We have to find this one and N. Okay. the given bandwidth value is 100 kilohertz. Have to find the 2df. How to find the 2df? Formula is f2 minus f1 divided by 2. f2 is frequency 2, nothing but 300 minus 200 divided by 2. I will go to get 50 kilohertz. I have find this one. This one is over. This one is over. I have find carrier frequency. Now I have to find the bit rate. I have to find the bit rate. Okay. B is equal to 1 plus D into S plus 2 delta F. For this, have the value 100 plus 1 plus D. D value is 1 into S plus I have this value is 50 kilohertz. So I will get 100, it is equal to 2s plus 50, and I have to calculate the s value. Okay, I have to calculate the s value. So I will take this 50 to this side. Okay, so I will get 2s is equal to 100 minus 50. So I will get 50. Okay, now I will take 2 this side. I will take 2 this side, means s is equal to 50 divided by 2. I will get 25k bound. Okay, I get the value yes, but they are going to ask to get the value for n, not for s. But we know that always signal rate is equal to bit rate. So whatever value I am getting for signal rate, same value for bit rate. So n is equal to 25 kbps, means the signal rate is represented by baud, but bit rate is not represented by unit bit per second. You have to mention bit per second, not bound. Okay, why I am taking same value for s and n means always s value is equal to n, means signal rate always is equal to bit rate. Another problem is there. This is second problem under FSK, frequency shift key. Here problem statement is there. We need to send 3 bit at a time at the bit rate 3 Mbps. The carrier frequency is 1 megahertz. Calculate the number of levels, nothing but different frequency, the bound rate and the bandwidth should be calculated. Means we have to calculate bound rate and bandwidth. Okay, given r is equal to 3, means need to send 3 bits. Okay, r value is 3, n value, bit rate is 3 Mbps, 2 df. 2df, nothing but carrier frequency. 2 delta f is given by 1 megahertz. Now we have to calculate the number of levels, means L I have to calculate, S means bound rate I have to calculate, nothing but signal rate I have to calculate. Bound rate is nothing but signal rate I have to calculate, and B bandwidth. Bound rate is nothing but signal rate. Okay, S represent the signal rate or bound rate. We know that to calculate L, there is a formula. L is equal to 2 to the power of R. We have the value for R. L is equal to 2 to the power of 3. I am going to get 8. Means I calculated the value for L. Now this part is over. Second, I have to calculate the S value. Okay, I know the formula. S is equal to N into 1 by R. Okay, I have N value and R value. N value is nothing but 3 year. Next, R value 3 year. I will substitute, I will get 1 bound. Okay, next one is I have to calculate the B, means bandwidth I have to calculate. So I will take B is equal to 1 plus D into 2 into 2df. I will take all this one is replaced by 8 and this will be replaced with 1. So I will get 8 megahertz. So B value is 8 megahertz. Okay, this is the end of FSK. Today out of this 4 I explained ASK and FSK. In next video I will going to explain PSK and QAM. Okay, thank you.